Okay, to solve question 55, the first thing we have to do is by hand we have to find the product of these first two matrices. The reason we have to do this by hand is because in the calculator we can't use this x and this negative y. So we've got to do that in order to find out which corresponding elements or what the corresponding elements are that equal -4, -9, 2, and 6. What I mean by that is when you see this equal sign and you see matrices, equal matrices have to have the same dimensions. And then when they do, their corresponding elements, like the element in row 1, column 1, is equal to the corresponding element over here in row 1, column 1. So we have to multiply these two matrices to get equal dimensions. The reason we know this is going to be equal dimensions, we have a 2 by 2 over here, a 2 by 2 here, and a 2 by 2 here. Because this is a 2 by 2 times a 2 by 2, this can be done. But again, the reason we know that, we check the inside dimensions and they must be equal. And if they are, the resulting product matrix is the dimensions of the outside rows of the first, columns of the second. And if you think about this, a 2 by 2, 3 by 3, 4 by 4, 1 by 1, you can multiply those matrices, and the product matrix will always be the same size. So we've got to multiply these by hand, and what we know is it's going to be a 2 by 2 matrix, row 1, column 1, row 2, column 1, row 1, column 2, and row 2, column 2. It's going to have 4 elements in those corresponding positions. Now when it comes to multiplying by hand, remember, we have an element that's made up of rows and columns. Well, the rows always come from the first matrix, and the columns always come from the second. Now remember, multiplication of matrices is not commutative, which means the order does matter. Okay, this times this is not the same as this times this. So it's always rows of the first and columns of the second. So here we have, okay, row 1, column 1, we need to find that element. Well, what's the first row in the first matrix? And the first row is 2x and 1. Okay, times column 1. Column 1 comes from the second matrix, okay, and we have 1 and we have 2. Okay, now we're going to add these together, and when we add them together we get 2x plus 2. So that's now the new element in row 1, column 1, okay, in our product matrix. So now you can either move left to right or top to bottom. We'll go to row 2, column 1. Now because we're still in column 1, you'll notice that this is still 1 and this is 2, but now we've moved to row 2, and remember rows come from the first matrix, so we have a 2 here. Sorry, I don't want to put that there. We have a 2 here, and we have a 0 here. And when we add these together, that new element is going to be 2 plus 0, which is just 2. So that's the new element in row 2, column 1. Okay, now we're going to move, or go back to row 1, but now we're going to move to column 2. Now keep in mind the rows are the same, so this is still going to be 2x and this is still going to be 1. But now we are going to column 2, so this is going to be 3, and this is going to be a negative y. Okay, when we add these together we get 6x minus y. So that's the new element in the product matrix, row 1, column 2. Okay, and last but not least, okay, we have row 2, column 2. Okay, so here we have the same row as we did in this particular product. So we're going to have a 2 and a 0. And then here, we're going to have the same column. So we have a 3 and we have a negative y. And when we add those together, we simply get 6 plus 0, which is just 6. Okay, so our new matrix is 2x plus 2, 2, 6x minus y, and 6. And that is equal to, go back up here, is equal to this, so -4, -9, 2, 6. Okay, this is a really good sign, 2 and 2 and 6 and 6. So now we have equal dimensions. We want to check that to make sure corresponding elements are equal, and the bottom row is, so that's good. So now we just have to solve the top row. And then the top row, 2x plus 2 has to equal a -4. and 6x minus y has to equal negative 9. What's going to be easiest to solve here for x first? X is equal to a negative 3, and so now when we substitute that in here, will allow us to pretty easily solve for y. We have negative y is equal to 9, therefore y is equal to negative 9. So the values of x and y in this particular problem are x is equal to negative 3 and y is equal to negative 9.